flow control as well as error control to achieve the delivery of the data from one node to another. And again, communication could be two-way, and in that case receiver and sender would switch roles. Protocols are normally implemented in software by using one of the common programming languages, and our discussion, we are not going to stick to any software or language, but it's all algorithm. The flow control is an algorithm, so we'll use some kind of a pseudocode, and that pseudocode would explain the logic behind this flow control as well as error control protocols. So these protocols fall into two major categories. One is the noiseless channel, and the other is noisy channel. As we saw in chapter 3, I believe, that there are no such things as noiseless channel, but in some ways it's possible to estimate that, well, there's not going to be any noise, or the noise, as we saw, the errors could be 1 in a billion or much higher numbers. So in those kind of cases, we could go ahead and use these protocols. There's one called simplest, the other is called stop and wait. For noisy channels, which are more practical, there are protocols called stop and wait, and that's where the error control comes in. So it's an automatic repeat request that's generated by the error control part also, because there's a possibility of the noise. In case of noiseless, there is no such thing. So you have all these automatic repeat requests, or ARQ is the acronym for that. There's go back N ARQ, and then selective repeat ARQ. These are the three major protocols, and there are of course variations of those as different systems require, but these are the basic protocols. And for noiseless channels, let's first look at that. So that's the left side of the taxonomy tree that we just looked at. So as I say, simplest and